Hello and welcome to Empowered Learning. This is the fifth video in the Radical Expression series, and what we want to do in this particular video is deal with expressions that are fractions but also have radical expressions in the numerator and or denominator. And so we're going to start off by talking about examples B and D, which you can't see now. We'll talk about those first and then finish up doing examples A and C. So what we want to do is add or subtract the following rational expressions and simplify. And we want to assume that all variables are positive real numbers. So let's move on to example B here and talk about how we actually work this out. So if we look here, we see that we have 4 divided by 2 times square root of 3 plus 1 over square root of 5. And like we mentioned in the part 4 video, that here we need to get rid of these expressions with the radicals in the denominator. And we want to do that by rationalizing the denominator, okay? The very first thing that we see, low-hanging fruit here, is that 4 divided by 2 is just 2. So we could take this and just simplify that, and that's why we have 2 divided by square root of 3 here. And of course, we just write the plus 1 over square root of 5 there. Now from this point, we want to rationalize our denominator here, and the quickest way to do that and be able to add these fractions here at the same time would be to first figure out what the lowest common denominator would be for square root of 3 and square root of 5, which will be square root of 15, and use that fact to be able to basically change what 2 times square root of 3 looks like and 1 divided by square root of 5 looks like, so that we have those equivalent fractions so we can add them together. So we see here to get 2 divided by square root of 3 with the denominator of square root of 5, we multiply both numerator and denominator by square root of 5. And to get 1 over square root of 5 to have a denominator of square root of 15, we multiply numerator and denominator by square root of 3. Okay? And so what we end up with is 2 times square root of 5 over square root of 15 plus square root of 3 times, square root of 3 divided by square root of 15. And then, of course, if we add both of those together, we end up getting what we see here, okay? So from that point, now what we need to do is rationalize the denominator with square root of 15. So we know we can do that since it's just square root by multiplying the denominator by square root of 15 and the numerator by square root of 15 too. And of course, we're doing both numerator and denominator because we're basically trying to find an equivalent fraction. So this is like multiplying this by 1, but we make 1 look like square root of 15 over square root of 15. Okay, and that's the same thing we're doing here and here. So if we do that, then of course, with square root of 15, we can distribute that to both terms in the numerator. And of course, in the denominator, square root of 15 times itself is just 15. Okay, so from this point, we take square root of 15, and we just say it's square root of 15 times what was in the numerator. We go ahead and multiply through, so that would be 2 times square root of 15 times square root of 5, which we can rewrite it this way. And of course, square root of 15 times square root of 3, we could rewrite this way. And we notice here that 15 has a factor of 5 and a factor of 3. So we see we have 2 factors of 5 under here and an additional factor of 3. So to make sure that you understand where I'm coming from with that, we are saying this. Okay? And so, of course, we could rearrange this to be square root of 5 times 3. And, of course, 5 times 5 is 25. And, sorry about that. And here we could split this up to be square root of 25 times square root of 3. And of course, this is just 5. So that's why you see here, when I do square root of 15 times 5 here, I split it up like this, and I know that the 5 times 5 inside of here is just 25, and square root of 25 is 5, okay? And so thus 2 times 5 is 10, and then we have a remaining square root of 3 that's left over, okay? So that's how we get that first part. For the second part here, we still see that we have square root of 15 times 3. And so similar to what we've seen here, and I'll go ahead and erase this and do it over so that it's very clear to everyone. So we have square root of 15 times 3, which is square root of 5 times 3 times 3. And of course we have 2 3's there, so we could pull one out. Let's look at it like this, and of course square root of 9 is just 3. So we have 3 times square root of 5. So that is where we get this expression in the numerator from, okay? And so now from here, we see that we have a 10 and we have a 3. And so all that I've done now to try to simplify this, I could leave it in this form, or I could break it up as a separate fraction and reduce that way. So leaving it like what we see here, this is an acceptable form, but I just want to step further to show you that if we were to look at this as 2 separate fractions being added together, 10 and 15 have a common factor of 5. So we just have 2 times square root of 3 over 3 for the first term, and 3 and 15 have a common factor of 3. And if we looked at that, that would be 1 times square root of 5 divided by 5, okay? And so this would be the final answer if we wanted to write it as 2 separate fractions being added to one another, okay? So, and there's a lot of little things going on there, but if you can follow it, then you can pretty much do any example where you're asked to rationalize a denominator. So we're going to go ahead and look at example D, and then after that, turn around and work A and C together, okay? So let's go ahead and look at example D now. So again, for example D, looks like it has a lot going on here, but we're just going to take it one piece at a time. So the first thing we see whenever we work this is that we need to get a common denominator. And of course, the LCD for the denominator square root of x minus 3 and square root of x is just square root of x times square root of x minus 3, okay? It's basically multiplying them both together. So we see that the first term is missing square root of x, so we multiply numerator and denominator by that. And the second term is missing the square root of x minus 3. So we would multiply square root of x minus 3 for both numerator and denominator. And of course, that's what you see here, okay? So multiply numerator and denominator by square root of x. Multiply numerator and denominator by square root of x minus 3 for the second term. And of course, when we multiply all this out, I'll get rid of all this stuff now. We see that for the first term, square root of x times square root of x is just square root of x squared, which would just eventually just end up being x, since we're assuming that x is greater than 0. We also see that for here, 5 times square root of x minus 3, we just rewrite it this way, and of course we keep our denominator together, okay? Now, in the next step, we go ahead and multiply the square root of x by both terms in the denominator here, and we get square root of x squared, which is absolute value of x, and since x is assumed to be greater than 0, that just ends up being x. Of course, here we're assuming that absolute value of x here is just x, since x is assumed to be greater than 0. So we have x plus 15, which is here, minus 5 times square root of x, which is there. Okay? And so now from this point, we're looking and we're saying, okay, well, we have a common quotient here, but we still need to get rid of this square root of x in the denominator. So how we're going to do that is we're going to multiply the numerator and denominator of this particular quotient by the conjugate of x minus 3 times square root of x, which would just be x plus 3 times square root of x. Okay, so we're going to multiply the conjugate by that, and that's we'll multiply the quotient by the conjugate, and so that's what you see here. And so doing that to the denominator is pretty simple. We just take whatever uses formula here, a squared minus b squared, the same thing as this. So basically we identify a as being x here and b as being 3 times square root of x, and just square both of those and take the difference. So we see that we do that here, and we get the result of just x squared minus 3 squared times x. Okay, and so that ends up being just x squared minus 9x in the denominator. For the numerator, we go ahead and we treat what we see here as two binomials here. So, and I'm keeping the x plus 15 together so that we can use the FOIL method. So we're looking at this like a minus b, and this will be c plus d. So we'll multiply a and c together to get x times x plus 15, and then we'll multiply a and d together, okay, just like how we would if we were doing the FOIL method. We multiply the outer together, and that will be 3 times square root of x times x plus 15, and then from there, let's go ahead and move this, get it back to where we had it. And then from there, we would do the inside, which would be minus bc, which is minus 5x times square root of x. And then the last, which would be minus bd, which would be minus 5 times square root of x times 3 times square root of x. And of course, square root of x and square root of x is square root of x squared, which ends up just being x. Okay, so we got the 5 times 3, which is 15, and then the square root of x times square root of x, which is just x. Okay, so from there, we would go ahead and distribute the x to both terms here, distribute the 3 times square root of x to both terms there, and we get what we see here in the numerator. And once we work all that out, we see that we have 15x minus 15x that cancels to 0. And then we see that we have, what is it? 3x times square root of x. And we see we have 5x times square root of x. So we could take these two terms here and combine them to be a negative 2x square root of x. And then of course, here, these two terms are common or like terms because they both have a square root of x in it. So we essentially just factor out the square root of x out of both of these terms and just write it as x squared minus square root of x times 2x plus 45, all that in parentheses, and then divided by what we said our denominator was, which was x squared minus 9x. Okay. Now, of course, I know that's a little messy, but again, I wanted to give a variety of complexity on some of these videos so that those of you that need to um, deal with radical expressions that are like this, you'll be able to see that, as well as for those of you that um, that don't have to deal with some that are as complex as these, you'll know how to deal with that as well. Okay. All right. So we've looked at examples. What is it? B and D, and we're going to pause for a second, erase, and then work on examples A and C together. All right, so now that we've went over examples B and D, we're going to work on examples A and C together to close us out here. All right, so we want to write this, or we want to add these two fractions together and try to simplify. So the first thing that we recognize is that we have two fractions with unlike denominators, so the LCD of these two fractions is going to be square root of 2 times square root of 3, which is square root of 6. So in order to form that, we need to multiply the numerator and denominator of the first expression by square root of 3 and the second one by square root of 2. So if we do that, we have square root of 3 plus square root of 2, all that over square root of 6. Okay? And so then from there, we know that we cannot allow to have a radical in the denominator. So here we need to multiply numerator and denominator by square root of 6. To get rid of that, our denominator here would just be 6, because square root of 6 times square root of 6 is just 6. For the numerator, we go ahead and distribute. So we'll take this and distribute to both terms. So square root of 6 times square root of 3 is square root of 18, plus square root of 6 times square root of 2 would be square root of 12. Okay? And so then from there, we know that square root of 18 can be rewritten as square root of 2 times square root of 9. And we know that square root of 12 could be rewritten as square root of 4 times square root of 3. And all that over 6. So square root of 9, we know that that's just 3. So that will be 3 times square root of 2. Square root of 4 is just 2. So that'll be plus 2 times square root of 3. All that divided by 6. Okay. And of course, from here, we could leave the answer this way, or we could go a step further and write it as two separate fractions if we wanted to. And if we did that, then we know that 3 and 6 reduce to 1 over 2, and 2 and 6 reduce to 1 over 3. And so with that, our final answer would end up being square root of 2 over 2 plus square root of 3 over 3. Okay, so this answer here is acceptable. This answer here is acceptable. So however you decide that you want to leave it, both fit all three criteria for a rational expression being simplified to its lowest terms. Okay. All right, so now that we've gone over example A, we're going to go ahead and tackle example C to round this up now. Okay. So same type of thinking here. We know that these are fractions that have unlike denominators. So what we need to do is find a common denominator. And of course, the LCD for these particular fractions is just square root of x times 1 minus square root of x, which if we multiply it through, it would just be square root of x minus x here. Because square root of x times itself is just x. Remembering that x is assumed to be greater than 0. So with all that being said, we know that we need to multiply the first expression by square root of x minus x, and oh, sorry, not that. Forgot about that. We need to multiply the first expression by 1 minus square root of x, numerator and denominator, and the second one by square root of x in numerator and denominator to make everything work. So if we do that, then we just have 1 minus square root of x minus square root of x, all that over the combination of 1 minus square root of x times square root of x. And of course, we know in the denominator that's just square root of x square root of x minus x. And then we have 1 minus 2 times square root of x. Okay. So from this point, we still see that we have the radical in the denominator. So we need to multiply the numerator and denominator of what we have now by the conjugate of square root of x minus x, which is square root of x plus x. Okay. And so for the denominator, we see that we just have square root of x squared minus x squared. And for the numerator, we're going to treat this as two binomials. So this would be like a minus b times c plus d. So we're going to do the FOIL method. Okay. So in doing that, I'm going to say 1 times square root of x is just square root of x. That didn't turn out so hot. So we will try to rewrite that. Okay, and then we do the outer, 1 times x, which is just x. The inner, which is a negative 2 times square root of x times square root of x, which is just x. And then the last, which would be a negative 2x square root of x. Okay. And then from there, we're just going to simplify as much as we can. So if we come here, we know that our denominator is just going to be x minus x squared. Our numerator, we just have square root of x minus x, because x minus 2x is just a negative 1x. And then this will end off with negative 2x times square root of x. Okay. And so we see here that we have two terms with square root of x, so we can combine those. And that will be square root of x 1 minus 2x minus x, and then all that divided by x minus x squared. Okay. And so in this form, this would be the final answer. If we wanted to, we could factor out the common factor of x in our denominator and split this up as two separate fractions. But again, that will probably get into a situation where it's way more complicated than what it's worth. So just for simplicity's sake, we will end there and use it as the final answer. And just in case that's not clear to everyone, I'm just going to rewrite what the final answer is here by erasing some of this, making sure that the final answer is clear to everyone. So that final answer again is square root of x times 1 minus 2x minus x, all that divided by x minus x squared. So that is what our final answer ends up being. And so we'll just keep it in that form. And so with that, concludes the video sessions on radical expressions and how to add them, subtract them, multiply, divide, and basically just trying to simplify them to lowest terms.